Welcome to today's class. We'll be going through function pointers in C++. So let's get started, right? So with function pointers, they are literally the same as like normal pointers. The only difference is that we are treating functions as data, right? There's many reasons why we would want to do that, but yeah, you'll start to understand. I hope you can see the reason why when you get to practical one, yeah, when you get to practical one. So we have this concept called OOP, right? Which stands for Object Oriented Programming, right? So what does that mean? OOP, right? So we have this thing called OOP, which stands for Object Oriented Programming, right? So basically, what this means, right, is we are trying to mimic the real world. The real world meaning the world you and I exist in. So this world that we exist in, it's full of objects, right? If you look at yourself right now, the device you're using, whether it's a phone or it's a computer, we call that an object. Anything that's physical that you can touch, right? That you can touch, see, sense, smell, especially if you can see it and touch it. We call that an object. It could be a pot, it could be a spoon, it could be even be a, it could even be a person, right? So any objects like a spoon, fork, a car, a person, which is you, and etc. Many more. Even a plastic bottle or Coca-Cola. That's what we call an object. It's a thing. Object is basically like another word for like a thing. Just in quotation marks, we're just saying it's a thing, it's something, right? So they're trying to introduce you to that, right? But before we get to that, they're trying to show you what was the way of doing it inside C before we get to C++. Remember C++, right? C++ is an ex I wouldn't necessarily say it's an extension, but technically it is. But yeah, but just phrase it in this way so that you understand. So C++ is an extension of the language called C, right? If you have experience with C, you'd understand. If you don't, that's also fine. But then the thing that I like to do is if you look at the way they've named it, it's sort of like a joke, Nyana. If you look at it, it's C++, right? We have the plus plus there. Where have you seen plus plus? Inside for loops, right? Where you have something like int I is equals to 0, I is less than some value, any value, and then you have I plus plus where we increment. This is a post increment operator, right? So if you remember the post increment operator, we just increment, we add by one, right? So the way they've named it, they're trying to like symbolize that it was an extension or it sort of like was derived from C. And then they added extra things, right? Like OOP, which is this thing of representing objects, right? So we have a way of representing objects inside computer, right? So we create something called a class, of which it's technically a record structure with functions, right? So this is the goal. We're trying to get to OOP, but then how do we get there? We need to start by C. It's parent, right? Remember, C++ is a child of C. So we need to understand the parent. How did the parent used to do this? So it used to try. Okay, I'm sure right now, for those people using C, they usually use function pointers because in a way it sort of like mimics OOP, but then it's still not OOP, but it sort of like mimics or copies the way the modern languages like C++, Java, Python do object-oriented programming, right? Trust me, you'll fully understand it once you get to practical one. Next week's practical, you will understand what I'm talking about. So we're trying to mimic that, right? But then in order for us to get to this part, we need to understand how do they implement it in C. So the way they would implement it in C, right? I mean, technically, you should be literally implementing it in C, but then that's a topic for another day. So what would we say is a function pointer? So a function pointer it's still a pointer, right? But then it's a way of it's like a means or a way for us to treat a function like data. Because what we have here, right? If you look at this record structure, right? Whenever you create a record structure, so let's create a simple structure, right? Let's say we're creating a structure to represent a person, right? So if you understand very well what a structure is a way to group related data. The keyword is data, right? A function is not data. Another term for data that we can use, we can just say variables, right? Because variables store data. So we can just say data is, in essence, we are talking about variables. So the main thing I'm trying to say is that a struct or record structure can only store variables or data. So since we can only store data, how would we try to group um, related information inside this record structure, especially if it's like functions? How do you include functions now? Since this record structure can only accept data. Well, the way to do it, okay, let me test something. Just let me test if it can actually accept a function. I've never tried it, but let me see if it can actually accept a function. Okay, it can. Oh, yeah, it can. So it can accept a function. Surprising, but the record structure is mainly for data, right? It's a means or a way of grouping related data. By related data, meaning that this data is part of one thing. In this case, in terms of the OOP terminology, would call this an object or a thing, right? Of which that's true. A person is a thing. You are a thing. You're a physical thing, right? But then you already call a living thing. There's non-living, then there's living. You'd what we'd call a living thing, but you're still a thing or something that's tangible, that's visible, right? Or another term for it is an object. Would say you are an object, or you are a living object. You are a breathing object. You breathe, right? So we have this. We can record structure. We can only structure data, or we can only represent group related data. So what is this related data? It can be anything related to a person. Or okay, let me not say a person. Let's make a different example. Let's say student, right? So in terms of a student, we have a student, right? So we try to create what information or what data would we want to okay, in terms of yeah, there's a difference between data and information. So let's just say data. When it's because at this point it's unprocessed. So let me just say data. What type of data would we want to get from the user, or what type of data would represent a student? What type of data would that be, right? First of all, maybe we can want the student's age. That's a possibility. We could want that. Second of all, we could want, for example, what else? Your name. So let me include string, right? There we go. So we could also want your name, right? So I'm gonna say, okay, I don't have to say standard. So I can just say string your name, right? We could want your name, and then we can create a function, right? Let's just say it's a simple function. Let's just make it as simple as possible. No calculations yet. We might add, I'll see. We might add, we might have to add an extra function just for calculation to see. But then I feel like you only need one example to understand. So how would we define the function? So the way you define the function is you type the return type, right? Which is a data type. So what type of data will be returned? That's what return type in essence mean. What type of data type will be returned? So after that you put a space, and then after the space you put the brackets like this, and then you put a pointer, and then you give your function a name of function, right? And then within the brackets, right, you then put in the parameters or a parameter list, right? You then do that. So we have this set, this rule, right, or this formula of declaring a function. So let's declare a function. So the return type, I just want to display the user's age and name. So I'll call it void, and then brackets, and then the name of the function, let's call it greet user. Let's call it greet user, right? It greets the user. But then remember, we are dealing with the record structure. It only works with data. So since it only works with data, I have to make it a function pointer. So the moment I make it, the moment I put a pointer next to the name of the function, it becomes what we call a function pointer. So a function pointer is it's in general, right? There's the real reason that there's like proper definition for it, but then for the sake of simplicity, I'm gonna say a function pointer is a way to treat functions as data. Because remember with pointers, right? What do pointers store? They store an address. So since they store an address, in essence, or technically, we can say that it's just data because an address is just data, right? So therefore, function pointers can be treated, we can say that it's actually data. But then it's not really data, it's just gonna store the address of a function, of another function, right? So we have this, but then we still need to add our parameters. What parameters are we going to take? So in this case, we are not going to take any parameters, right? In this case, we're not going to take any parameters. So yeah, let me leave it like that. It's going to have no parameters. So it's going to be parameterless like this. So therefore, I've declared my function pointer, or I've declared a variable that will store the address of another function. That's all there is to it. It just stores an address to the address of another function. Why am I saying another function? Because we're actually implementing a function. I can see that through these brackets. If I just left it like this without these brackets at the end, C++ would treat it as a variable or a pointer. That's how C++ would treat it. So we have our record structure. There it is. So let's do the right thing. Let's create a student, right? So I'm going to create a student, and then I'm going to say student, just just give it the simple name, student. So we have this student, right? For now, I'm making it as simple as possible. We'll get to the extra information, right? So student, there it is, student, done. We have a student, right? So since we have a student, let's get the information, right? Simple, like we usually do. So it's going to be student.age, and then I'm going to get the age, right? Or I'll just make things simple and just put in the age. So I'm just going to say 20, right? Just a random value, and then student.name. Remember what this means, right? When I say student dot, it means go inside, go within the record structure. And then once I'm inside the record structure, there's three things. I have a variable named age, and I have another variable named name, and then I have a function pointer, or a pointer that will store the address of another function, right? We typically call it a function pointer. So these are the three pieces of data that I have. But then there's something that's missing. What's that? What's missing is, okay, after using the dot, what's left is age dot name dot greet user. That's how you access or get the things that are inside the, okay, that's how you get to access the things that are inside the record structure. You just use the dot or the member accessor operator. It's actually called a member accessor or member access operator. So we have this. So let me give this person a name. Let me think of a name. Let me name him Ayana Koji, right? So we have Ayana Koji, who's 20 years, and then that's the piece of data we have, right? So now let us output that piece of data. So I'm going to say student.age, and then I'm going to put an end of line character or a new line, and then I'm going to output the student's name, and then I'm going to output an end of line character. So we have this piece of data, right? So now let's test it out and see if it's at least running. If it is running, we should see this piece of data. I could add extra information, right? But then I'm just testing it out. So you see it's working perfectly fine. We have this information. So since we have this information, we now know that there's nothing wrong with our record structure or our code so far. What I would do is I would try and implement the function pointer. So remember with pointers, right? If you remember pointers, this is how pointers work. You'd have int point, right? And then a, or let me just say int a is equals to 90. And then int pointer b is equals to something, right? So what's that something? The something is I need to initialize it to an address. So I need to say address of A, right? This means that the pointer is going to store an address of A. Remember, pointers store addresses. Typically, they actually do store both, but we use them to keep track of addresses. That's the main reason we use pointers. We want to keep track of addresses. So since we want to keep track of addresses, we have the address of, the value of this pointer is going to be the address of A, meaning this pointer is going to have access to this value, which is 90. So let me show you. I'm going to output the point. I'm going to point to B, right? Remember we said if you don't put the asterisk, right, or you don't put the pointer next to the variable on its own without the pointer, it just means it's the address where that thing stays, right? Which is this address that we've stored there. That's the address that's stored in the variable name without the point. Now, when we point or put a pointer there, we're saying go to that address stored inside B and get the value or the contents of of the contents of that address, right? So I'm actually getting the value because I want to see or show you guys that it's going to output the value 90. And you'll see if I change A, B will also be affected. So let's start with the basics of pointers before we can continue. We have 90. It's perfectly fine. That's what we expected. Look at what happens. If I change this to 800, now it's going to output 800, right? Because if it outputs, it's going to output 800. It's going to output 800, and then when it outputs 800, we know that it has the address of A. So since it has the address of A, then we know that there's the pointer is working perfectly fine. There's that link. We have the address of where A is stored inside our computer's memory. Because remember, every variable, just like us, everything that we have is stored somewhere or in an address, right? We in a computer we'd say that's an address. So if I want to store my pencils, right, I need to store them inside a pencil case. So we'd say the pencil case is located at a specific address, right? Because that's where we've stored the pencil. Just like we do it in the real world where we store things, and we also stay at houses, we live in a specific house at a specific address. Also variables, every time when you declare them, they are stored at a specific address. So we have that, we know that we have that link, our pointer is working perfectly fine. So since everything is working perfectly fine, now let us try and mimic this approach of pointers with only variables, but then now with functions. And since we have functions, it's also going to be a bit different. It's going to have we're going to do it in terms of functions, right? So how do we do that? So the first step is to create this function, right? To mimic it outside. So you need to say void, and then you need to give it a different name. Obviously, you can't give it the same name as this one. You are not obliged to give it the same name. Typically in your in your code or in your memorandum, it's gonna come back looking like this. You're gonna prefix it with imp, meaning that it's for implementation, right? Remember, this is just the function pointer. So I need to point to a specific function's address, right? Because that's how pointers work. They need an address, just like here. We used an address to point to that address and then get the value of that at that location or at that address. So I'm going to say imp, and then I'm going to call it grid. Yeah, I would just give it a different name. And then if you look at my parameter list, right, it's empty. In this scenario here in this function, it's empty. So that's right, because it needs to match with the function pointer. If I had maybe an integer a there, I would also have to pass in an integer there. I don't necessarily have to name it a. Remember, you don't have to name it a. I can just name it B if I wanted to. But then in this case, I don't have any parameters, so I'm going to leave it like that. So you have header files, right? And CPP files. I'm not going to do that. So this would go in your header file. Right? We would call this a function prototype. Basically a plan or how the function is going to be sort of like how do I put it? It's sort of like how the function it looks, right? What is the return type? What are the parameters? Only that. We don't provide the implementation. We don't implement the function. When you only have that piece of data with when we have the return type and the name of the function and the parameters and no implementation, we would call that a function prototype because it's just a prototype. We haven't implemented the actual thing. If you know the word prototype, it just means it's like incomplete. It's like a plan. So here, this would go in your CPP file or implementation file where you've actually implemented the function. It's called separation of concerns, if I'm not mistaken, where we're trying to not put one thing inside one file. Because if you put one thing inside one file, it becomes hard for maintenance later on. So imagine when you want to add an extra thing, it's going to be a bit untidy if you have, for now it's easy because you have like 36 lines of code. In big applications, you have up to 5,000 lines of code. So imagine one file usually has, in that big system, one file normally has 5,000 lines of code. Imagine trying to combine each of those files and you have 10 of them. That's going to be 50,000 lines of code inside one file, which is not necessary because it's going to be hard to maintain over time. So let's implement enough of the token. Let's implement the function. So in order to implement the function, right? Okay, I forgot one thing. You see the problem here. If you check, how will I point to that student? Which student am I pointing to? Because remember, this is a record structure. I need to get a student, right? So how do I do that? So I need to pass in a student pointer or a student address. Remember, pointer just an address. It's a way for storing addresses. So I need to pass that pointer. So even my function that's going to implement, that's going to have the implementation, it needs to match my function pointer. As you can see, it matches exactly as it is. Remember, this is not the function pointer, it's actual function, so I don't need to put that pointer there. So just remember that these parameters need to match. The parameters and the return type, they need to match. Then you give it a name. You give your function a name. I prefer you start with imp so that you know that it stands for implementation. It's an implementation of it's an implementation that you're gonna use to initialize your function pointer. So we have that, and then I'm gonna scroll down and then I'm gonna copy and paste that parameter there. So I have the parameter, it's there. There's the parameter. And then now what I need to do is implement, because now I have the student. This is the student. But then if you remember with pointers, you see here, we need to dereference. I need to point to that address, because if I just use student, this variable name student on its own without a pointer, it's an address. I'm not actually changing anything. I'm just, it's not, I'm not getting the actual value. You get what I'm saying? So I need to get the actual value. So I need to dereference and then say student, right? And then remember the student, it's a record structure. So I need to use the dot or the member accessor operator. So let's do that. But remember, this is a greet function, right? It's meant to greet. So I'm going to say cout, and then I'm going to dereference or point to that address stored inside the variable student. And then I'm going to say dot age, right? And get the age. But then, as you can see, it's very cryptic. It's very cumbersome. It's like, it's untied. It gets confusing, and it might confuse the computer. The computer will be like, okay, what do you mean? Do you mean I'm pointing to this address, or this whole thing is the address? So it gets confused. So we need to put parentheses or brackets around this one so that it knows, oh, okay, you only mean this and not including this. You only mean this name is the one that stores the address. Then you can use the dot and get the age. There's a better way to do this. I'll show you that later. Let's just write it. I want to show you the many different ways. Let's write it in this way. And then I'm going to have an end of line character. So I need to also output the tag age like this before I output the user's actual age. And then I'm going to output the user's name. And then we're going to do the same thing, point to that address or go to that address, get the student. And then remember, the student that we're getting is a record structure. So I need to go within the record structure again. So I need to say dot and then get the name. And then I need to put an end of line character there. And then I'm done. I've implemented my function, right? I've implemented the version or the function that this function pointer needs to point to, right? So how do I call it? Or how do I implement it? Not how do I implement, how do I initialize this function point? The same way you'd initialize a pointer. But then now it's a bit different because it's already declared here. in this case, right, look at this case. In this case, I was declaring it. What C++ doesn't appreciate is that it won't appreciate if this pointer when you initialize it like this and then you put it when you're declaring it the first time and initializing and then you put a value there, it won't appreciate that. It will actually wants an address because that moment when you're declaring it, it has no address, not pointing to anything. But then after this line, I can just use the variable name of that pointer on its own without a pointer. Then I'm actually referring to the address. Let me show you. So I'm gonna output B here without the star or the pointer. And you see it's gonna output an address, right? That's what we expect. And then once I put that name of the pointer, including the pointer, then it actually goes to that address or it points to this address. So as you can see, this is the address. So the variable on its own, this variable on its own without the star or the pointer, it's actually an address. So I'm going to use that same knowledge to initialize my function pointer. So what I'm going to do is I'm going to say student, right, dot, and then I get the greet user method. And remember, if you use it without the pointer, right, then it's going to be the address. So I'm actually accessing the address. So the address, what do I want? I want to initialize it to what? Imp greet, right? But then I don't want to initialize it to that function. I want to get the address of the function, just like we did here. We have an address for a variable. Here we're dealing with functions. That's why I implemented a function. So I want to get the address of a function, and then I've initialized my pointer. Let's build and test. Hopefully there's no issue. Yeah, there shouldn't be an issue, but yeah, just making sure. So far, if I build and run, nothing should happen. Yeah, because I haven't called the function. The greet user pointer function, it has been initialized. It has the code now. So what's going to happen is it's going to take the address or go to the address of where this implementation is. So every time I call greet user function, it goes to this address of this function that was implemented here. Hence, we've initialized it to that address of that function. So now let's call greet user. So you call greet user the way you'd normally do it, right? You'd say student dot greet user. Remember the brackets, and then it wants a pointer of basically the pointer is like to refer to which student you're current. That parameter is a pointer to help us to help the computer remember which student you're referring to. So I'm gonna pass student, right? But then it's a function pointer, so it expects an address of student, right? Remember function pointers or pointers, they work with addresses. Look, address. Look at the function pointer, it requires an address. Look at this pointer that I have as a parameter here. It requires an address. This part, don't worry about this part. I was still implementing it, so I didn't have to pass an address. Once I call the function, it's a different case. I need to pass an address. So here I'm calling the function pointer. So here I'm calling the function pointer, right? Or basically the pointer that points to a function. That's a pointer that is the address of a function. In simple terms, that's what it is. As you can see here, isn't this the address of a function? What is imp greet? Imp greet is a function. So therefore it points to a function or the address of a function. Hence the name function pointer. And then we're going to build and run. I should expect to see output, right? Hello, what is this age and name? And the specific user's age and name. As you can see, there they are. It's working perfectly fine. So that's, in a nutshell, that's how pointers work. Let me see how long the video is now. Okay, it's not too bad. So let me just see if there's anything extra thing to explain. So that's, in simple terms, that's how function pointers work. You need to initialize the function pointer, right? That's the first step you need to do, the function point, meaning that you need to take the address of another function. That's what function pointers are for. It just points to the address of another function. The reason why we need to do that is because record structure is a data structure. Data meaning it's a way of structuring data. So it expects pointers and variables. So that's why we're like, okay, you think you're smart. We'll use your pointers that you accept, but then now we're pointing to functions. So this pointer here can only point to the address of a function. You can initialize it to an address, but then I'm saying its main goal is to point to the address of another function. So therefore, it's going to take the address of impgreet, which is another function. So this is what's going to happen when the code runs. It's going to start at the top. It sees this. Okay, it acknowledges you've declared that. It sees you've declared this, all of this, and then it gets here to this part. It's like, okay, what's going on? It's like, oh, okay, I need to use this variable, right, which is student. And then I use the member access operator to access the record structure and access the function pointer. It's like, okay, what's create user? Oh, it's a pointer. So this user has called it without the pointer. So this means they are referring to the address. So therefore, on the right-hand side, I'm also expecting an address. If I had referred to the pointer, the function pointer itself, right, it would have been very cryptic. It would have been something like this, like pointer, like this, right? It would have been like this, which is a problem. Let me see if it is even going to compile. Yeah, it's going to be a problem. So you'd have to, okay, I think the main issue should be this right-hand side. But then usually you're just gonna initialize it like this. Just call the name on its own, because the name on its own, remember here, we did this example here. B on its own here is just the address. If you mix the two, you put a pointer and address, you are pointing to the address. You are going to the address and getting the actual value. Here, we don't want to get the function because there's no function. Remember, at this point, we're still trying to initialize it. You can't access a function that you still haven't, there's no implementation. Look at it. Is there implementation here? Did we implement this? No, we didn't. So here it would complain. Yeah, it would complain at you or scream at you and say, what's going on? I'm confused. What function are you calling, or what implementation are you calling? Because they haven't implemented anything. So we have this, and then we have this, we initialize it to that address. So you could, okay, it's fine. Let me not add that comment. Let me not add extra information that's going to confuse you. So just know, you remember, this is the normal way of calling functions. Just put the student on the side, the student dot. You see, this is the normal way of calling functions, right? The only difference is that now it's within the record structure. So I need to go to this variable student and then access using the member access operator, get the name of the function. You don't have to put the pointer now. It already points to the function. That's dealt with. That has been sorted. And then remember, this function takes in the current student, right? That you are displaying information for. So for the current student, in this case, you can't just pass it as a student because we expect a pointer, or it expects an address. So you need to pass an address so that it won't scream at you and be like, okay, you promised me a pointer or an address. What is this now? So in essence, that's function pointers. And then so obviously every function pointer that you have, I just forgot that piece of detail. It always needs to have this. Always. Because if you don't have this parameter, how will you refer to the student? You get what I'm saying? So it becomes a problem. So you always need to have this. If you have extra information, right, you can also have this. You can have int, right? And then you can have a string and so forth. And then you'd also need to update this implementation now to match that parameter list. And then have int and what. It depends on the number of parameters you have. So this is pretty much function pointers. If you have any questions, just let me know. If you look at your slides, there's a convenient way of writing this, right? Because this is problematic, right? You can't write this all of the time. You can also write it like this. You can remove the dot and the star and the brackets, and then just put an arrow like this. You see, it starts showing me what's inside the record structure, which is age. So this is a better way of writing it, because this, you might make a mistake and forget this, this brackets, right? The parentheses, and then it might face issues. Let's test it out. You should face issues, yes, because it's gonna get confused. Like, okay, do you mean this address or this whole thing is the address? Where am I pointing to exactly? You see, so you might forget those parentheses or brackets, and then your code might crash. So let's run it again and test it to see if it's working with this new way that we've seen. It should work. Exactly. So there it is, it's working, still the same. You can choose which method you want. You can stick to this way of accessing, or you can use this way, especially if you have a pointer like this. So yeah, that's it for this video. If you have any questions, let me know.